Hello, dear seekers of knowledge and harmonic explorers. Welcome to CognitionChunks. This is From Fibonacci to Frequencies, the Golden Ratio in Pythagorean Tuning. The golden ratio, often denoted by the Greek letter phi, is a mathematical constant approximately equal to 1.618033988749895. It has fascinated mathematicians, scientists, designers, and artists for centuries due to its unique properties and its appearance in various natural phenomena, from the branching of trees to the spirals of galaxies. The golden ratio is defined algebraically by the equation, frac a plus b a equals frac a b equals phi, where a greater than b greater than 0. When it comes to music theory and Pythagorean tuning, the golden ratio does not directly intersect with the traditional Pythagorean tuning system, which relies on simpler rational fractions based on integer ratios. However, there are intriguing areas where the golden ratio and musical tuning overlap, offering a rich tapestry of ideas, both theoretical and practical, that traverse the realms of mathematics, acoustics, and aesthetics. Theoretical connections. 1. Harmonic series. While Pythagorean tuning focuses on integer ratios like 2 to 1 for the octave and 3 to 2 for the perfect fifth, the harmonic series itself extends infinitely. Some music theorists have speculated that the golden ratio may be an irrational harmonic, sitting outside the boundaries defined by integer ratios but still connected to the natural resonances of sound. 2. Temporal proportions. The golden ratio has been identified in the timing structures of certain musical compositions, although not in tuning. For example, the climactic moment in some pieces of classical music occurs at the point dividing the length of the piece according to the golden ratio. 3. Fractal geometry in music. Some contemporary composers are using fractal algorithms based on the golden ratio to generate pitch sequences, rhythmic patterns, and even form in their compositions. Practical applications. 1. Instruments design. Although traditional acoustic instruments are not designed around the golden ratio, some modern instrument makers have experimented with using the ratio to determine the proportions of their instruments, aiming for an aesthetically pleasing design that may also have unique acoustic properties. 2. Music production. In digital music production, some artists and engineers apply the golden ratio to elements like the timing of chord progressions, track lengths, and even equalization curves, albeit these are time-based rather than tuning-based applications. Philosophical implications. 1. Beauty and aesthetics. The golden ratio is often associated with ideal beauty in visual arts. Its appearance or non-appearance in musical tuning systems may raise questions about the universality or cultural specificity of aesthetic ideals. 2. Mathematical pluralism. The coexistence of multiple tuning systems, including those that incorporate irrational numbers like the golden ratio, calls into question the idea of a single, correct or natural mathematical approach to understanding musical phenomena. 3. Musical semiotics. How we interpret the meaning or emotional impact of different tuning systems could be influenced by broader cultural narratives around mathematical concepts like the golden ratio. Limitations and controversies. 1. Psychoacoustic evidence. There is limited empirical evidence to suggest that the golden ratio possesses unique psychoacoustic properties that make it more pleasing or effective than other ratios when applied to musical tuning. 2. Historical accuracy. claims that the golden ratio was used in the construction of ancient instruments or in classical compositions are often not supported by rigorous scholarly analysis. In conclusion, while the golden ratio doesn't inherently fit within the Pythagorean system of tuning based on integer ratios, it presents a captivating multidisciplinary subject that brings together music theory, acoustics, mathematics, and philosophy. Whether or not it offers superior musical qualities is a matter of ongoing debate, but its broad array of theoretical and practical applications makes it an endlessly intriguing topic for further exploration. As we conclude this enlightening episode, let's pause and recapitulate the intricate connections we've mapped out between the world of Pythagorean tuning and the mesmerizing phenomenon of the golden ratio. Our expedition started with the inception of Pythagorean tuning, its mathematical precision and how its philosophical underpinnings go far beyond mere musical practice. But then, we entered a realm where art, science, and math intersect, the world of the golden ratio. This mysterious constant, denoted by the Greek letter phi, has been found in architecture, art, and even the natural world. Could it be that music is yet another medium through which this ratio manifests itself? We broke new ground when we delved into the properties of the golden ratio and its mathematical definition. How astounding was it to discover that the same golden mathematical relationship present in a nautilus shell, a sunflower, or even the Parthenon, also finds resonances in the intervals of Pythagorean tuning. That moment when we understood how this ratio provides an elegant solution to the Pythagorean comma was truly a conceptual epiphany. Our analysis didn't stop there. We moved on to the socio-cultural implications. From the pentatonic scales in Eastern cultures to the harmonic complexity in the West, the variations seem endless, yet the golden ratio serves as a kind of universal constant. It's as if this number is a hidden thread that connects diverse musical traditions. Then came the speculative yet thought-provoking part. Could the golden ratio be the key to a universal music theory? We discussed intriguing theories that posit the universality of this ratio, not just in the physical realm, but perhaps also in the cognitive and perceptual domains. A truly transcendental idea that raises more questions than it answers, fueling our appetite for understanding. We even touched upon computational musicology, where machine learning algorithms have detected the presence of golden ratio-like proportions in various forms of music, again hinting at some deeper, hidden order. To conclude, this episode has been a marriage of numbers and notes, ratios and octaves, phi and frequencies. If your mind is as blown as ours, do us a favor, smash that like button, subscribe, and ring the notification bell, because, at CognitionChunks, our symphony of knowledge is an endless crescendo. Thank you for tuning in to another intricate tapestry of thought, sound, and universal principles. Until the next enlightening episode, keep your minds open and your thoughts harmonious. Signing off, CognitionChunks. Was this accurate? Did GPT just make up a bunch of stuff that does not exist or does not make sense? Find out next time in the CognitionChunks follow-up.